In this section of lecture, we are going to learn about gas laws and laws that align with the properties of gases. The first law is going to be called Boyle's law, discovered by the scientist Boyle. It states that for a fixed amount of gas at constant temperature, the pressure and the volume of the gas are inversely oppositely related. Inverse relationship means if one quantity increases, the other one must be decreasing. Let's discuss this. So we are at constant temperature. Temperature is not increasing. The pressure and the volume of the gas should be inversely related. I'll have to introduce you to another law. This is called the ideal gas law. Ideal gas law gives us the relationship of all other laws. So I'll be deriving all the laws we are talking about from the ideal gas law, which is pressure P times volume V equals to number of moles of the gas times the gas constant. R is 0.08206 liters atmospheres per mole Kelvin. So PV equals to N, number of moles of the gas, R, the gas constant, times temperature. So if we are saying we are keeping temperature constant, so this is a constant, call it constant C. R is a gas constant, call it C, and we are also keeping the number of moles constant C. So we can say that pressure times volume equals to constant, because everything to the right is constant. And therefore, if PV equals to a constant, call it C, or K if you want, then I can say P is going to be equal to my constant over my volume. Or I can also say P equals to 1 over V times the constant. See where I'm going? So now look at this. If you want to remove the constant here, we'll use a proportionality sign, like pressure is inversely proportional to volume. That is the idea. So P, the pressure, is inversely proportional to volume. So if I'm increasing the volume here, the pressure is going to go down. If I'm increasing the pressure, the volume is going to go down. So that is the relationship in Boyle's law. Okay, so we read again. Boyle's law states for a fixed amount of a gas at constant temperature and at constant moles amount, the pressure and the volume of a gas is inversely proportional, which is this relationship. Now here I used the constant C, but you can also use the constant K. So you can say PV equals to a constant K. Call that a constant, misspell it with a K. And therefore, if you divide both sides by V, that's what I was trying to do, you get that P equals to 1 over V times your constant. Okay, so again, to remove the constant, we use the proportionality sign. P is inversely proportional to volume. So P, pressure times the volume, equals to a constant. We continue to discuss Boyle's law using an illustration here. If the volume of a gas cylinder is multiplied by a half, it's halved or reduced by a half, the pressure of the gas inside the cylinder should double. It's very true, because we just said that pressure is inversely proportional to volume, right? So if this is 0.5, what will be P? It will be 1 over 2. Then P will tend to be 2, right? Because this is the same as 1 times 2 over 1. Pressure will double. Suppose you have a setup where you have a cylinder with a piston in it. So if you apply pressure, meaning you push this down, force it down, force per unit area is pressure, that means that you are increasing pressure, increasing P going downwards. You are starting off with 1 atm, but you're applying pressure, now it goes to 2 atms. What you're noticing here is that the volume is decreasing to that much space or volume. The number of molecules are the same: 1, 2, 3, 4, 5, 6, 7, 8. 8 molecules, just like here you also have 8 molecules. Remember, Boyle's law states that when you have a fixed amount of gas at constant temperature, the pressure and volume are oppositely related. So N is constant, and that aligns with Boyle's law. Remember, we generated Boyle's law or derived Boyle's law from ideal gas law, which states pressure times volume equals to moles of a gas times gas constant times temperature. So N is constant, R is constant, you can say K or C. Temperature is kept constant, and we are told that at constant temperature and in fixed amount of gas, N is constant, pressure is inversely proportional to volume. PV equals to a constant. All these are constants. And so if I know that pressure times volume is a constant K, then I'm telling myself that if I have initial conditions of pressure, initial conditions of volume, it must be equal to the multiplication of PV initial must be equal to the multiplication of P after, P final, and V final. So if we have initial conditions multiplied of P and V, it must give us the same answer as multiplying the after conditions of P and V, pressure and volume, because they are always a constant K. So if we know that, we can take advantage of that and do an example. How to use Boyle's law to calculate a new gas volume or pressure. That is the learning objective here. Example number 1 reads, if a 4-liter container of helium gas has a pressure of 10 atmospheres, stop there. So we are given V1 to be 4.0 L, we are given P1 to be 10.0 atm. What pressure does the gas exert if the volume is increased to? So we need after pressure P2, and then we are also given V2, the after volume, increased to 6.0 liters. So we do know that PV equals to K. So P1 V1 must be equal to P2 V2, because it's always a constant when you multiply those two. So what I need is P2. I need P2. So I can divide both sides by V2, and the new expression would be P1 V1 over V2 is gonna be equal to P2. That is a new expression, and based on that, now you just plug in the numbers. 10.0 atm times 4.0 L divided by V2 is 6.0 L. Now doing so, you can cross out the liters. You are left with atm, and the answer here will be, so we have 10 multiplied by 4, and then we are dividing by 6. So my P2 will turn out to be 6.66 recurring atm. Our question gave us a unit in 2 sig figs, so it's 6.7, because 2 sig figs will end up here. 6 is greater than 5, so we round up the other 6 to a 7. So the after pressure will be 6.7 atm. That's how you solve this problem, and you can check your work. You are increasing the volume, so the pressure must decrease. Remember, pressure is inversely proportional to volume. The pressure initial was 10 atm, the volume was 4, you increase the volume to 6. So if you're increasing the volume, increase in V should be decrease in P, and that's what I see. The P decreased to 6.7, initially it was 10. So that's how you do that, and you'll see The same process followed here. You are dividing both sides by V2 like I showed you before. You end up with this expression, and then you just insert your numbers. Remember liters, and liters must go. This is P1, that's V1, this is V2. You end up with 6.666 recurring, but we have to report to two sig figs, so it is 6.7 because this 6 here after 6 is greater than 5, so this 6 here is rounded up. Easy to do. Before we do more examples on the other side, let's see an application of Boyle's law. You're looking at a human body, and that's a nose. Someone is inhaling, meaning taking in some gas. The rib cage expands and the diaphragm lowers to give space. The diaphragm is this area right here. This area is the diaphragm. So the diaphragm lowers. As it lowers, it increases the volume of the lungs, so the lungs can accommodate the air that you just took in, or the oxygen. So increase in volume causes the pressure to decrease. Okay, so you're increasing the volume, and then the gas has more space, so there's less pressure. Air is drawn into the lungs to equalize the pressure. That is the idea. Okay, so it helps to breathe. It helps us to breathe during inhalation. Okay, so what you're seeing here is, firstly, the volume was increased, and that led to decrease in pressure, so we don't feel pain when you are inhaling. As you exhale out, the rib cage does the opposite. It comes together. So what you're doing, you're decreasing the volume. Okay, decreasing in the volume of the rib cage increases the pressure within the rib cage, and the result, the gas or air is gonna be expelled out, because now inside the rib cage there is increase in pressure, so the air is gonna be expelled out to equalize the pressure to accommodate the smaller volume outcome. Okay, so that's the application. Let us look at more calculations of Boyle's law. Question 1, Boyle's law. A gas sample contained in a cylinder equipped with a movable piston occupies 300 ml at a pressure of 2 atm. What will be the final pressure if the volume were increased to 500 ml at constant temperature? So the first thing I'll have to do is to write Boyle's law. PV equals to K, which means P1 V1 equals to P2 V2. And then I come down here and I give the givens. So what am I given? I'm given P1 to be 2 atmospheres. I'm given V1 to be 300.0 ml. So these are my initials. And then my after is asking me what will be the final pressure if the volume were increased to. So I'm given V2 500 ml. What will be the final pressure? P2, I don't know. That's going to be the needed. So I know that P1 V1 equals to P2 V2. I need P2. So I'll have to divide both sides by V2. That expression will now read P2 equals to P1 V1 over V2. And then all I need to do is to insert my given. So 2 atmospheres is the initial pressure, 300 ml is the initial volume, and my after volume is 500.0 ml. So doing so, ml and ml will cancel. My answer should read something atmospheres. And if we can do the math, it will be 2 divided by 500, then multiply by 300. So it's giving me 1.2 ATMs, but I have to report it to 3 significant figures. Because I have 3 sig figs versus 4, I'm going with 3. That is gonna be our P2. Another example of Boyle's law: a balloon that contains 1.5 liters of air at 1 atm is taken underwater to a depth at which the pressure is 3 atmospheres. Yeah, the more you dive into the water, then the more the pressure increases, which is why the submersible imploded. Calculate the new volume of the balloon. Assume that the temperature remains constant. Again, I'll remind myself Boyle's law: PV equals to a constant. At constant amount of gas, constant temperature. So initial pressure times volume is gonna be equal to after final pressure multiplied by final volume. So I'm asked to calculate the new volume. So needed here is gonna be V2. I'm given P1 to be 1.00 atm. I'm given initial volume to be 1.5 liters. I'm given after pressure, the final pressure to be 3 atms. So since I know P1 times V1 equals to P2 times V2, since I know that and I need V2, I'm going to divide both sides by V2, by P2, so that P2 and P2 here will cancel. So my V2 will be equal to P1 times V1 divided by P2. So I come here, I say V2 equals to P1 times V1 over P2. P1 is 1.00 atm. V1 is 1.50 liters. P2 is 3.00 atm. Now we can multiply this together, but let's get rid of the SI units. And then now we can punch the numbers. This is just 1.5 over 3. Remember, the answer is going to be in liters. That did not cancel out. So 1.5 divided by 3, you know the answer is going to be 0.5. And I see the least sig figs I have is 3. So that's how I'll express my answer, and that is our needed after volume. It told us to calculate the new volume of the balloon. It turns out to be 0.500 liters as the answer.